All right, Newton's first law states that a body in motion will stay in motion at a constant velocity and a body at rest will stay at rest unless acted upon by a net force. And, we spend a lot of time doing that with the law of inertia. And we use the hockey puck example where the hockey puck, continues at a constant velocity. As long as there's no air resistance, no friction, it just keeps on going. With Newton's second law, a body accelerates when acted upon by net external force. And the acceleration is proportional to the net force. You double force, you're going to double the acceleration, or you triple force, triple the acceleration, half the force, half the acceleration. And it will also be in the direction the force acts. So if you have a mass, like a box here, and the net force is to the right, it's going to accelerate to the right. And we used, one of the most important equations probably of our whole year for us in Physics 1, F equals ma. And mass is in kilograms, acceleration is meters per second squared. And, we get the net force equals ma, the sum of the forces, the net force equals ma. And we can determine the acceleration of the system. Now for Newton's third law, for every action there's an equal and opposite reaction. And, if you have a positive force A, and, you're going to, and let's say you're pushing on a wall, you're going to get the equal and opposite force, negative force B, and back equal and opposite. All right, so this one here, H12, we have a toy car being pushed with a net force of 14 newtons. What's the car's acceleration? So go ahead and pause the clip and give this a try. When you're ready to check, you can hit play to continue. Okay, so we have our mass, force applied. We should get 3.11 meters per second squared for the acceleration. And that's the acceleration of the system. We get the net force of 14. Okay, what would happen if the force is double? Go ahead and calculate the acceleration. So go ahead and pause the clip and do that. And when you're ready to check, you can hit play to continue. All right, so for that one, we should get 6.22 meters per second squared. So twice the force, twice the acceleration. All right, so if we push this toy car with a force of 28 newtons, and we got the acceleration after 6 seconds, assuming that it's starting from rest, what's the car's velocity and what's the displacement? So go ahead and pause the clip and use your equation sheet there. See if you can draw this out, write out the variables, and work through that. And when you're ready to check, you can hit play to continue. Okay, so we've got our acceleration, and we can find our final velocity by using final velocity equals initial velocity plus acceleration times time. 37.32 meters per second is how fast it would be going, and it will be 111.96 meters will be how far it will go during that portion. All right, so H15, we have a 325 Newton box. How much mass is that? And then what is the weight of a person whose mass is 75 kilograms? So go ahead and pause the clip and get these, and then when you're ready to check, you can hit play to continue. All right, F equals ma, and we know the force of gravity, and we know the acceleration due to gravity on Earth. This box's mass is 33.16 kilograms, and force of gravity, mg, 75 times 9.8 would be 735 newtons. That would be the weight of the person. So remember, weight is also force of gravity, right? Same thing. You just want to recognize that force of gravity is weight.